Okay, so what we did yesterday was basically built the ANN structure. Alright. So today what we'll be doing is pre-process the data and then feed it to the ANN. Alright. So we'll learn to pre-process the data, okay, the various steps, and then we'll feed that data to the ANN model so that it can learn. Alright. After that, we'll basically perform evaluation, okay, just to see how accurate the model is, and then we are done with the meet. Okay, that's all what we're going to do for today. So screen is visible. Okay. Mm, okay, so this. Okay, so uh, importing libraries. This is basically the first step in almost anything. It's not necessary you need to import it first. Okay, you can import it anywhere, but before you use it, just import it. All right. After that, this statement is just to check whether the library has been imported. For example, here we are checking if for the TensorFlow version. If it isn't being imported properly, then it will basically show the version that it is. Currently, it's on 2.18. 2.2 and above that is practically useful. Okay, not useful. It's like more better compared to the previous versions. Okay, because a lot of things have changed. Particularly, they have integrated Keras into TensorFlow, so using a version of about 2 is better. Okay, in most cases, 2.0, just version about 2.0. Okay, apart from that, okay, this is the main pre-processing stages. Okay, so yesterday I'll again just do a recap. So we basically imported the sequential class, all right, in order to build the ANN architecture. We first imported the sequential class. After that, we added layers one by one. Okay, so first, okay, so the input layer I told gets automatically added based on the input data that you give to the sequential class. So you don't need to separately specify the input layer, it is automatically added. After that, we add the hidden layers. Okay, so in this particular code, we have added two hidden layers. So the first one here, okay, and the second one. And in this hidden layer, we have used the activation function of rectified linear unit that basically prevents any linear pattern or any linear, you know, what is it, linear feature that has been detected. So it basically breaks that leniency. And in each of this layer, there are six neurons or six nodes, you can see. Okay, so here there are six neurons. It has an activation function of rectified linear unit. In this again, we have six neurons, an activation function of rectified linear unit. After that, we added the output layer, okay, in which we have one neuron, okay, which basically gives an output of either, it gives a probability output since the activation function is sigmoid, okay. Now then we can, take the probability and then tell, like the Yash or the model output can be that whether the person is going to leave or no. Either it's true or it's false. He's leaving, so it will be true, and if it is not leaving, it's going to be false. Okay, so that is what this layer does. It gives the output of probabilities. Then after that, we compiled our ANN model, ANN architecture. Now using the loss function as binary cross entropy and the optimizer as Adams. Okay. Now what does the loss function does? It basically calculates the loss after each epoch. Now, what is an epoch? Epoch is a run through the entire data. Okay, whatever data set we give it, once it goes through each of the inputs or each row of that entire data, we call it an epoch. Okay, so now the loss can be calculated either after the entire epoch or after every particular reading. Okay, like it goes through one row and then it calculates the loss. Okay, I'll come back to that later when I tell you all about the the ways the training can be done. So getting back to the loss function, we used here binary cross entropy. So in order to calculate the errors, since we are getting an output of probabilities over here, since the output of probability is being given over here, and our data set output is either 0 or 1, we use binary cross entropy to calculate the cost. Okay. Then apart from that, we use Adam optimizer. Now, the different ways in which the weights are adjusted is by using optimizers. Okay, so Adam is a type of stochastic gradient descent. Now I told about the stable states of models yesterday. So the lowest point it can get is the most stable state. Okay, for the cost for the output, predicted output versus cost graph. So the lowest point in that graph is the most stable state, and optimizers help us reach that. There are two kind of optimizer. One is gradient descent and one is stochastic gradient descent. All right. Now, this is to compile the model. Once we do compiling, we need to give it the data, and it will basically train. Okay. Now, what kind of data that will be discussed today? That's the main purpose of today's lecture. But before going to that, again, I'll do a recap of the types of training. So yesterday I told, right, there are three types of training majorly. So one is you either go through the entire data set, like the model will go through the entire data set, and at the end it will calculate the average loss. All right. So this is done using this gradient descent. Okay, the optimizer called gradient descent. So when we use an optimizer, so here if we use a gradient descent kind of an optimizer, it will go through all the data first, and at the end it will calculate the error. Okay. Now, what are the benefits of this? So, if we do gradient descent, right? If we use gradient descent as an optimizer, our our model will be quite stable. It will learn the features in a stable manner, and the gradient descent will be quite accurate. So, see, I give you all an analogy of the helicopter view, right? Once you look from on top, like once you look below from on top, you have an idea of like what is going around, but you don't have a detailed idea. In general, you know what is going around. So similarly, the model knows in general what is going on. So it has a good generalization of the data. So in like if I try to put it in machine terms, it has an accurate gradient descent. Okay. But a downside of this is it is quite slow. So just imagine going through all the data, okay, and then you calculate the cost. Then again you have to go back and adjust the weights individually again. All right. So that takes a lot of time, and it is very memory intensive. All right. It requires a lot of we will say GPU power. Now the other type of optimizer is stochastic gradient descent. Okay. Now what this does is it goes through each row. Okay. It will go through each cell in single cell through the of the this what is that of the input data. Now this entire thing is one cell. This entire thing is one cell. So it will go through all this, and then it will adjust the weights. Okay. Then it will come to this one. It will go through all this, adjust the weights. Now the downside of it is that it is what to say, the gradient descent that we calculated, right? It is not quite accurate. All right. It has a lot of noise. Okay. Now the fact that it has a lot of noise is also an advantage to it. Because of this noise that is introduced while we train it with stochastic gradient descent, it is able to avoid the local minima. I showed you all the graph, right, where it had multiple minimas. Okay, so the lowest point is the global minima which it has to reach. Apart from that, there could be various local minimas which it has to avoid. So by using stochastic gradient descent, we introduce noise into the model's training. See, when we go through each of this cell, it will adjust its weights. So now it has an initial weight. Now when we go to this, it will be able to, basically optimize its previous weights. So it already has this one weight, so it will optimize it more in order to get a good output. Now when you go to the second one, it will again optimize. So, but when it's doing this, it will be more like once we do this cell, right? It will be more lenient towards getting this output. Now when we come here, it will be more lenient to getting one. But since it is a zero, it will take some amount of time to basically, train itself in order to get this zero. Okay, so this is called noise. So there will be some biasing that's going on. So this is the only downside. Apart from that, it avoids this local minima, which is important while training models. Because usually it's not just a convex graph; it is having multiple minimas. out of which we have to get the local minimum. So that is why stochastic gradient descent is of prime importance. Okay. Apart from that, we have mini batch, which is mostly used. Okay. What mini batch does is it goes in batch. This also I told you yesterday, right? So it takes like a batch of 10. So it will apply stochastic gradient on each of them. Okay. No, sorry, not on each of them. It will apply this gradient descent on this entire thing, calculate the cost for each of this block. Okay, this is one batch, then there will be another batch. So for this batch, it will calculate the error and adjust the weights. So by this, we reduce the noise, but at the same time, it's going to be fast because stochastic gradient descent is faster as compared to this gradient descent. And also, it takes less resources in order to do this. All right. So this is an advantage of mini batch. So you create small batches of the entire data set, and for a single batch, you will apply gradient descent. You won't apply gradient descent actually. So what you're doing is you're applying both gradient descent and stochastic gradient descent. We're basically combining the advantages of both. Okay, but in order to understand, in this batch, you're applying gradient descent, and at the end, you're applying stochastic gradient descent. Because see, this entire data set is divided into batches, so we can treat each batch as a single cell. But now each batch is not a single cell. All right. So what we do is for each batch, we compute the average cost and then we adjust it weights. Then we go to the next batch. So this is more beneficial compared to using either stochastic gradient or just gradient descent. Okay, so this is mini batch training, which is mostly used and it is very beneficial. All right. So that was the type of training. Then after that, what we have. All right. So after that is now once we have chosen the type of training to be mini batch training, we are going to basically give the input data, which is X train and Y train. So this is the training set. Okay. The batch size here is 32, epoch is 100. I've explained. I won't be doing it again. Okay. So let's go to this part. So X train and Y train. Now what we do first? First is we basically import the data set. Here p1.csv is our data set. Okay. This file. Sorry, this particular file. This is our data set. So we first need to import it in our code. So let's do that. Okay, so the method we use, okay, so the library we use it pandas. So pandas basically helps in managing files, while numpy is basically for manipulating the data in arrays. Okay, pandas is for the files. I'm giving in general, the way we use these libraries, and numpy is basically manipulating arrays and just playing with the data. All right. So what we do is we first import pandas, okay, and we basically give a variable name of PD. This is a shortcut, okay, to use it as short form. So what we do is pandas, so PD dot read CSV. So this is a method for reading, basically importing a CSV file or any type of file. So if it was some other file, we would have changed this CSV to that file type. Okay, say it was a text, so we will have changed it to a text, read underscore text, or I think txt, something like that. Okay, then we will basically import the file. So in this line, I've imported the file into a data set, into a variable that I've named data set. So now data set has all these data. All right. So it has all these data. Let me just- now the next step is separating the input data and the output data. So if we go here, so if we see this, okay, let's first look at the data set. So we have row number. This is not important. Okay, customer surname, basic customer ID, I guess. Then we have surname. Then we have a credit score for that particular customer, the location of that customer, the gender, the age, the tenure, the balance. What is this? Number of products. Okay, his credit card or not, and is he active. Then apart from that, the estimated salary, and this is the data whether the customer has exited or not. So this is the data that they have collected. Okay, now can any one of you all tell of you all here tell me which of these columns is actually important to us? And yeah, which okay, tell me which of the columns are not important over here. Anyone?
A geography, credit card,
I guess geography will be
gender.
important because he belongs to that particular region, right? So say I live. in a city A, okay, and the services over there are bad. So I have left it. Okay, so if I put in my data set, city A, most of the people are leaving. So that means there is some problem in city A. And in city A, and suppose there is a new customer tomorrow that lives in city A, there is a higher chance of him also leaving. Okay, because say suppose the facilities over there are not nice for that particular bank. So I guess geography is
Cool.
important. Has credit card? Yes, it is important. Okay, because I think that this decides whether the person is active or not. Also, if he has credit card, it's better to be with the bank. Okay, because that means he's having some amount also, right? Or is getting particular benefits, some cashback. So credit card will also have some effect. Tell me one thing: will the surname of that customer have any role in deciding whether he will leave or not? Is surname important? Like if I go today to a bank and I tell them my name, just by getting to know my name, will they be able to tell whether I'll be leaving or not? Means in future if I join.
I want to say yes, but no.
Yeah, the answer is no, because your name doesn't really, because in this case your name won't be contributing, right? So there can be two people named John. Okay, so here's the surname. So suppose say we take the name, there will be two people named John and John. So one person leaves, okay, one person doesn't. Now it's not that both the Johns left or both the Johns didn't leave, right? There was like 50-50 chances of him staying and leaving. Say suppose there is another person with the name John comes. Now if we have trained our model on these two Johns that where one stayed, one left, there is a 50% chance of either this new John that has come is either gonna stay or is either gonna leave. So there is no like one-sided out. So surname is not important apart from that customer ID. Does customer ID matter? Is it like important towards deciding whether he will leave or not? Suppose I'm the seventh person to go in a bank. Is it like the seventh person is gonna leave the bank, or the seventh person is certain that he's gonna stay with the bank for a longer time?
No.
Yeah. So again, customer ID not important. Then a row. Does this even matter? If I remove this, say I remove this entire, does this matter? Does the context of the data change? If I see, this was the first customer, this was the sixth customer. If I place him over here and I get this one down over here, does it really matter?
No.
Right. Exactly. So, see, this data is given to us by a bank. Now, the bank might have conducted a survey, okay, or done some campaign through which it has collected this data and it has given us. Now, our main aim is to see which of these parameters or which of the columns are going to contribute towards our output, okay, which are of significant importance. Name, customer ID, all these don't really matter. Okay, so we can avoid them. So what we do here is, so if you see here, data set, this data set is a basically the original data set, right? We have imported the file and not done anything. This is our original data set. After that, what we do is we locate. So we assign x a particular value. Okay, sorry, again I'm going to, okay, so we assign x the values from here to here. Okay, because this is our input data that will be giving the model. What the model has to predict is the output data. Okay, it has to predict this. So this is like the output data. Understood? See, once we got the
Yep.
main data, this is our main data. Okay, all this, including the uh, this entire thing is our main data. These three are ignored, okay, because they are not important. This entire thing is our main data. Now, in this entire data, since we are doing supervised deep learning, so what does supervised deep learning mean? So, supervised means we are giving it the input and also we are giving it an output so that it can train. All right. So now this is our entire data. So we need to divide it into the input section and the output section. So here, all these columns, uh, okay, all these columns from credit score to estimated salary, this is our input data. So while giving input to the model, we are going to give him the credit score, okay, of that person, the geography from where he is, the gender of that person, the age, the tenure, the balance, the number of products, either if he has an edit card, yes or no, credit card, yes or no, is he active, yes or no, and the estimated salary. So this is the input we are giving to the model. And what output do we actually want from the model? Is either he's going to leave or no, either 1 or either 0. All right, got it right? Understood the splitting of the inputs and the outputs?
Yeah.
Okay. So if we come back to the code, okay, let's do this side by side. Okay. So iLog is basically assigning a particular section of the data from the data set to this variable x. So what I'm doing is from this data set, okay, now in this, right, in this particular thing, you can see there are two inputs separated by commas or two parameters, input parameters. One is this and one is this. Is it zoomed in on yours? Because I put the screen. This is zoomed in, right, for yours?
Yeah, 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 it is.
Okay, okay. Cool. So in this ilog, we have two parameters. So the first one is the number of rows. Okay. Now, if you can see, there is just colon over here. This means that we are taking all the rows. That means from row 1 to the last row. Okay. So all the rows are taken. Now, the second parameter is the columns. Okay. So the third column. Now see, when we import a data, the columns are numbered as 0, 1, 2, 3, okay, and so on. So it starts with 0. Now we want the input like x, okay, our input data is from this D column, right, which will have a value of 0, 1, 2, 3. Okay, so it will have a value of 3. So we are starting from 3, and now you all can see I used -1. Okay, so, okay, one question. If I was not to use -1, all right? Say it's like this. 3 to what value should I put here? See, this is 3, right? And our input data is still here. So what is the value of m? Okay. So from here to here, I have to put this entire data, means this section of the data from this to this, from this to this, into x. Okay. So I started with 3, right? This is 3. So 3 to what? Anyone? So this is 3, 3,
It would
4,
be
5.
infinity or something.
What? Uh,
Like
could
if
you
you're not
please?
giving a right hand limit, it'll go like never stop.
Yeah, so what do you give? What will I put here? What value? You're right. If we don't put, it will just go on. Or it might just stop at n.
12.
Okay, I'll tell. So this is 3, right? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. But I won't put 12. I'll put 13 here. Because the thing is, see, if I put 12, right? What it will do is, it will take from here to L, to 11. What it does is, it excludes the last value. So it will exclude 12. So since I need 12, I need to put a higher number. A number higher than 12, that is 13. One number higher than 12. So it will take from 3 to 13. Sorry, 3 to 12. It will exclude 13. Okay. Now since, okay, in this particular data set, we just need to avoid the last row. Sorry, the last column. What we'll do is put -1. So what happens when you put -1 is, it takes from 3 till the second last column. So it omits the last column. Understood?
Yeah.
So what we did here is, from data set, we took from this credit score to the estimated cost, estimated salary. Okay. from that column to this column, and we took all the rows. If I don't mention values here, that means it's gonna take all the rows that are there. Okay, I can put from I can put this 0 to the last row. So for that, I have to go down and calculate the row number. I'm not going to do that. So if we just don't put any values, right, it's going to take the first value till the last value. So for rows, we need all the data, right? So it's going to take the first value till the last value. And after that, this is the column input, okay, the parameters for the column. So the starting column that is having a value of 3 to the second last column. Since the last column is output, it's going to come in the y data set, okay, in the y parameter. Currently, we are talking about the X parameter, which will have the input data. Input data ranges from credit score till estimated salary, okay, which has a value of 3 to 12, and 3 to 12. This column's number is 12. But since in this entire data set, we just need to omit the last column, we can put negative 1. Negative 1 takes the second last. It just omits this one, the last column. All right. Now for the output, okay, see X is the input, Y is the output. So for our output from this entire original data set, we just need the last column, right? And we need all the values. So all the rows are taken. Again, if you see here, there are no numbers, just a colon. Just a colon means we are taking all the rows, then separated by a comma. And then if you see here, there is no colon, there is just a single number. Single number means the last row. So the last row, we represent last row as negative 1. We can also put 13. If we put 13, it's going to give us the same thing, okay? Because the value of this nth column is 13. So if you count from 0, 1, 2, you will get 13 over here. So yeah, so two ways, either put 13 or put negative 1. Usually we use negative 1 since it's like easy, because sometimes we don't know how many rows are there and nobody wants to calculate. This is a very small data set. Usually there are like a lot of columns. So in that case, you will be using negative 1, because you need, like most of the cases for the basic model, there is like one output. Okay, it's either yes or no, or it can be a continuous value, probabilities, okay, either the name of a place. So what we use is negative 1 for the last column. Okay, for rows directly to semicolon. Say suppose you want to use just from the starting row till the say the 27th row. So what I can do is come here and I can put 27. Okay, so this will do what this will do is take the rows from here only till 27. So it will take just this much data. Since now we want the entire data, we remove this, and yeah, it takes the entire all the rows. So this was the input, that was the output. Now the next part is pre-processing the data. Now there can be multiple cases, okay, where your data is not perfect. All right. So say suppose you gave, now let's talk about just the data set. Okay. Now how do we collect data? We collect data maybe by through some campaigns. Then after that, survey forms, Google on Play Store, if you go, you'll get Google Forms occasionally. So survey forms occasionally. So apart from that, there are multiple ways by which you can calculate data, maybe through even web scraping. All right. Now, when once we get this data, it's not always that all the data, fields will be filled. Say suppose you gave a survey form, okay, and there are multiple fields in that. Say suppose one of the field is you are asking for the person's salary income. So say that person doesn't want to specify, he just leaves it blank. Okay, so in that case, once all the data comes to you, that particular field for that person will be blank. It will be not having a value. Okay, so and there can be many other cases. I'll discuss one by one. So let's discuss this one where values are missing in the data set. Now in this data set, all the values are present. But if you can see, there are multiple zeros over here. So this is a case where there could have been which were missing from this entire data set. Maybe the people like in the survey or when they collected this data, they didn't get this particular values. So what they did is they put zero. Okay. So this entire case where the data is missing is called basically a missing data set, right? Missing values. Now, how do you deal with this? Is either you put a fixed value over there, or what you'll do is you'll calculate the average of all the values that are given. Like once you get the data, whatever values you have for that particular input, like for that particular field, you'll calculate either the mean, okay, the standard deviation, or the median. and then you will put it in places where the data isn't present. Okay, or in some cases you may just delete the entire entire row, okay, for that particular input. But that's not beneficial because data is very important. So it's better to try to get another value present over there. So the first case is of missing values, where the values may be not present. So in that case, what you do is you either calculate the mean, the median, or the what is that, mean, median, and okay, I forgot, and the mode, okay, or the mode, and you basically put those values over here. Okay, by that you will be able to fill in the place where the data is not there. Now coming to the other case is where you will have inconsistent data. Now this is what I've experienced. So when I went to the Goa Police Hackathon in BITS, they gave us a data set. Okay, so what we were working was on basically a smart parking app. Okay, that basically helps you find nearby parking spaces. So in that they gave us like the location of the parking lot, the coordinates, okay, and like the amount of cars, okay, that you can park, amount of bikes or and truck or whatever. Okay, there were certain input fields. Now among those fields, right, there was this particular field of location, right, the basically the geographical, not geographical, the GPS location. Over there, right, the data was quite inconsistent. Now what I mean by inconsistent is, okay, in certain cases they had given us coordinates in brackets, okay, and it was like exact coordinates numbers, like 19.4 and comma 26 point, like that, something, okay, I don't know the exact numbers or the average. It was something like that. And in some cases they gave us with like 19.4 north and then 14.6 east, okay, somewhat like uh, so the data was quite inconsistent. It was not possible for us to train a model using that data set. So what we had to do is refine it, correct it. Okay. So now what we did was we basically converted to one form. So what form we took was just the numbers. So we tried removing the north, and it wasn't just simple as removing the n and the e. What we had to do is actually convert those coordinates into the other form. So there are basically two methods of giving a location. So like say there is form A and one more format B. So we had to like use formulas for converting this B into A. Okay. So by that we were able to make the data consistent. Now this is important for the model. Okay. So like if I'm training a model, okay, like to put it in simple terms, say there's a field of say the basic salary of a person. Okay. Take this field only, estimated salary. Now, say suppose in some cases I put it with respect to rupees, and in other cases I put it with respect to dollars. Okay. Now, when I train my model on that, do you think it will give me correct output?
No.
Exactly. Because we are using two different scales over here. One is in rupees, one is in dollars. They will be totally different values. So what we need to do is keep the data consistent in a row. If I'm having rupees in one column and dollars in another column, and those columns are basically separate, like it shouldn't be duplicates. All right. One more. Okay, I'll come back to that later. So say suppose I'm having one is estimated salary and one is the expenditure, and the estimated salary is like in dollars and the expenditure is in rupees, that will be okay. Okay, like that will make sense to the model. But if in the same column we are having uh, two different scaling factors, then that will not make sense to the model. Or even if the model try to make sense out of it, it will give us wrong outputs. All right. So the second case is when we have inconsistent data. So what we do in that case is basically make the data consistent. You either apply a formula, make a function, and convert the data that is not proper. All right. Now going to the third case, it is outliers. Okay. Now in a data set, okay, say suppose we, what is this, number of products, okay, say if you see here it's like one digit. Okay, no, there are, let's take uh, okay, let's take credit score. So in this case, like if you see there are three digit numbers, right? Say suppose all of a sudden in between there is a five digit number. Now that particular thing is an outlier. So if we feed that data to a model, it will basically get confused onto how such a big value got introduced into a data set that had like 3 digits. All right. So what we do in that case when we have an outlier, that is a very abrupt change in the values. Okay, so what we do in that case is we try to cap it. Now what do I mean by capping is we basically keep it to a particular threshold. Maybe we take the highest of all these and we basically cap it to the highest. Say suppose there was like the highest over here is 7, say suppose it's 800 and we had like 5 lakhs, so we'll convert at 5 lakhs to 800. Okay, that's one way. Or the other way is either you delete the entire column. Now, why I'm saying delete? Earlier I said data is very important. So in this case, if you see it's an outlier, that will cause a drastic change to the model, okay, to the learning of the model. So it will be better to delete it rather than keep it because it's just a single value. Because outliers, like they occur just like in one form. Okay, there won't be so many outliers. They can be, but usually it's one or just a few of them. So you can delete it. But in case of missing values, see if you see here only, there are like around 8 or 9 of them. So it will not make sense to delete 9 basically data that 9 rows of data that we collected, and it just won't be 9. There are a lot. Okay, so that will be a loss. While as deleting a single cell in order to prevent a much larger noise will be better. So the third one was outliers. Now, when we go on to the fourth one, it's basically different scale. Now, this is almost same to the inconsistent data. Okay, so I have explained, right, rupees and dollars. So what you do is you either keep it in rupees or you either keep it in dollars. You keep the scale same for the data in a single column. All right. Now, apart from that is categorical variables. Now, if you see here in gender, we either have male or female. Now see, these are strings, right? These are like words are basically called strings in program. Now, to convert this string into what the machine understands is machine language, that is ones and zeros. Now, to convert this string into binary, it will take some amount of time and some amount of processing. All right. After that, the model needs to process all this data. So, like if we convert this female, okay, word into a string, okay, it's gonna be easily over 8 bytes. Bytes. Okay, just consider it's gonna be easily over 8 bytes. Instead of that, what if we replace female by 0 and male by 1? That will just mean 1 bit. And having 2 bytes. Okay, sorry, I meant 8 bits. That's 2 bytes. Having 2 bytes and having 1 bit is like a big difference. Okay, 2 bytes correspond to 8 bits, and 1 bit, like there's a big difference between them, which basically means that the performance is going to improve. It's going to take less resources. So what we do is we basically convert this into ones and zeros. Okay, since these are categories. Now, in term, if it was names, say suppose we take this into consideration, it's not possible to categorize them. They will be having a lot of values. It will go to one, two, I don't know how many unique names are over here. So the thing is, we use categorical transformation when there are categories. Here, there are categories, female, male. Here also, we have categories that are countries, France, Spain. Here, it's not, they are categories, but there are a lot of categories in this column. Here, there are just two. Here, there are just three. Okay. So, use category transformation when there is basically a small number of categories into the column. Okay, in the column. So that is one transformation. Apart from that, again duplicate. Say suppose you have gender and you have another row that's called sex. Okay, these both have the same meaning. So there's no point of having two columns which have the same meaning. So what we'll do is we delete one of them. All right. So these were the few cases of data pre-processing. As you go forward, you will learn more of them. All right. So yeah, we have done the cases of data pre-processing. Now let's apply what we have studied. All right, let's go back to our code. Okay, so let's encode the gender column first. Okay, so this column you see, I told you already. You can change the male to 0 and female to 1. Any way works. It doesn't matter as long as you have zeros and ones. So how do we achieve this? So what you do is go to the library called scikit-learn. Now scikit-learn is one library. From that you go to the pre-processing module. All right, and do go through these libraries. Okay, this is very important because see, when you're making a model, you need to use tools. Now, unless you know about the tools, you won't be able to use them. What I'm giving you now is some tools that we use most often. Apart from this, there are so many tools. Okay, so what you need to do is go and read the docs. I know it's a lot, but so just read even maybe one module is enough. Okay, say suppose you go to scikit-learn, you go to pre-processing, and you only read about maybe string pre-processing. There are a lot of pre-processing. They can be image. Okay, in this case, we are doing basically for strings, right? So what we do is we go to the module pre-processing, and from that we basically import the label encoder. Now label encoder is a class, so what we do is now we create an instance of that class. So we have imported it. Now we are creating an instance of that class. Now since we created an instance, there is a method called fit transform. Now what is this method? Okay, now if you see, there are two words. The first one is fit and the other one is transform. These two, this entire function, right, can be divided into two functions. You can first apply fit. So what I can do is, okay, instead of having this, I can have only this. Okay, just ignore this. Okay, this doesn't. So I can do this. Wait, I can first fit, okay, this entire data with the label encoder. Okay, and after fitting it, I can transform. So what I can do is transform. This also works. Although the syntax will change over here, it won't be LE. I've just shown how the two functions can be used separately. But because in some cases you only need to use transform, you don't need to use fit. That is why this particular separation of the functions exists. Here it's combined. So what it's doing is it is taking x. Now x is the input data, right? So x is this particular thing, this entire thing. Now from that, what you do is, see, I told the first parameter is the rows. So you want all the rows from the start to the end. The second parameter is the columns. Here there is only one column. So we are only one number. So we are referring only to one column. If it was if it was 2 colon something else, then it will be from a range from 2 to 7. Okay, remember, we don't include the last column. We exclude it. Okay, so it will be 2 to 7. But here we just have one number. That means we are referring to the column number 2. Okay. Now again, the numbering will change. Since x is from here to there, x will start with 0 over here. 1, 2, 3. Okay, this will be numbered again. So credit will be having a value of 0. Geography will be having a value of 1. Gender will be having a value of 2, and so on. So what we do is of x, so of in this data set, we go to the one with 2. Okay. So this is 0, 1, 2. That means gender. Okay, because we are performing transformation on this. So what we do is we take this entire thing and we apply label encoder. Now what does label encoder do? Label encoder basically first takes the categories and after that it replaces it with 0 and 1. This is basically used for columns having just two categories. Here it has two categories, that is male and female. So it will either replace female with 0 or 1. Okay, so if female is 0, male will be 1. If male is 0, female will be 1. So that's totally dependent on how it does it. So LE is the label encoder, the instance of the class. We apply fit transform method. In that method, we give an input parameter for what column or what range of column we need to perform the transformation. In this case, it's just this particular column, the gender column. So the transformation will be applied on this entire thing. Okay, so if we do this, and also on the left hand side, if you see, it is taking in consideration only the second column of X. Okay, X is this entire data set. So it is taking in consideration only this particular one here. Okay, and here also the input is given as same. So now I'll run it and I'll stop. Right. So let's run this, run this, run this. I'll print X. Okay, just to show what changed. So if you see, X is from here to here. So 619, so 619, then we have the country, then we have the gender, and so on. And the last is estimated salary. Okay. Then what we did is we applied the label encoder. That basically is applied on columns having only two classes, and it replaces those classes with either 0 or 1. So once this is done, I'll print x. Now if you see here, it was male female. Here it got replaced by zeros. Okay, so female got replaced by 0. Okay, then if you see male, it got replaced by 1. All right. So now we applied label transformation on gender column. Now on what other columns can we apply is geography. So if we take this column, if we see here, we have three classes. Okay, now I know this is like the name of countries. So in this column, we just have three countries, that is France, Spain, and Germany. All right. So okay, so we have this three column. Now we can't just use label encoder here because there are three categories. So if we use 1 for France, we use 0 for Spain, then Germany is left with no value. So what we do here is we use one hot encoder. Okay. Now what this does is, since this has three columns, right, it will create binary columns. Now I'll directly run the code and show you what I mean by creating a binary column. So what we do is we go to scikit-learn again. Okay. Then we go to compose module. From that compose module, sorry, from that compose module, we take column transformer, which is a class. Now we create the column transformers instance. Okay, the instance is named CT. So we create an instance where the transformer is an encoder. Okay, so we need, in the input parameter, we need to specify what kind of transformer we are giving. Column transformer means, by the name you all should have understood that the entire column is going to be transformed. Okay. Now, what kind of transformer we are using? Transformer is basically like the function. What function are we using to change it? Now here we are using an encoder. Basically what it means is we are going to encode this France string into a binary code. Alright. Then what type of an encoder? One hot encoder. Now where do we get this one hot encoder? It is into pre-processing. So in Keras, another module, pre-processing, I think is the same one, right? So if you see here, pre-processing module, we had label encoder. Now for importing one hot encoder, we have, it's the same pre-processing module. Okay. So what is one hot encoder does? Okay, let's run this code. So we have used it here, and we are just using it for the first column. All right. So if you see here, where is our x? So this is our x. Okay, in this the column numbered 1. Okay, so if you see this is 0. Okay, this column is 0. This is 1. So we are taking this column and applying the transformation only on this column, and nothing else is being touched. Okay. So if we go back, okay, so we need to create an instance. Yeah. So transformation is created only on this column numbered 1, and the remainder is equal to pass through. So what does this mean? This means that the remaining columns, okay, now this is the entire x, right? This is the entire x. Uh, this is the entire x. From this, we are only taking into consideration this one. So what about this column, and this column? Okay, this, then this, all. What about them? What we are saying is just pass through. Don't touch it. Okay, just let it be the way it is. All right. So once we have created an instance of column transform and we have specified a transformer, we apply it. So now we'll use numpy. Numpy is basically for altering the array. So now in this x, right, in this x entire thing, in this input data, in this, we are applying the transformation, okay, fit transform, using the instance created from the column transform. So if you see this entire thing, it is like a 2D matrix or a 2D array. Okay. So using NumPy, using the library NumPy and using its method array, we are using the instance that we have created of the column transform to fit transform X. Okay. So this entire data we are applying on this entire data, we are applying the transformation. So what I'm doing is fit transform. Fit means basically calculating the values. Now what do I mean by calculating values? So if you see there are three. So it will basically categorize. Okay, so it will go through the entire data. It will see how many unique classes are there. So it will see there is Spain, which is unique. There is France that is unique, and there is Germany that is unique. So there are three classes. So now what it will do is it will create three binary columns. So what do I mean by binary column is each column will be either having 0 or 1. Okay. So France will maybe represented by 100. Spain might be represented by 010, and Germany may be represented by 001. All right. Since there are three classes, three categories. So that is the meaning of fit. What does transform mean? Transform means applying the calculated values to the data. Okay, so we know France is 100, we know Spain is 010, and we know Germany is 001. So now, when we apply transform, it means we'll replace this France, okay, we'll replace this France by 100, which will be the first column, the first binary column will be having a value of 1. The second one is going to have a value of 0, and the third one is going to have a value of 0. So in this way, we change France to its binary equivalent. All right. Now, I hope you all have understood what we have done here. Just give thumbs up or unmute and tell. Have you all understood what we have done? Chandrakant, Ved, Tejas, Anish. What about the others? Sairaj, Giselle understood. Okay. 7, right? 7 or 6 are done. Carl, okay. Others, what about you? We have 14 of us. 14 excluding me is 13 because I have 3 accounts. Okay. Okay, let's continue. So yeah, let's run this particular cell of code. Okay. Now let's print to see the changes. Okay. Okay. So if you'll see here, the first one, why did it? It got rid of this particular column. Okay, no, it's there. So if you see France, where is it? Okay, look from here. Okay, this thing is taken care of. So don't worry about this. Look at this. France has been represented by 0, 1, 0, 0. Okay, this three column represent this particular string. So France is 100. Then if we go to the next one, Spain, okay, it is 001. So Spain is represented by 001. Then Germany is represented by 010. Okay, so this is what one hot encoder does. So it one hot encodes it. So based on the number of categories, it will create binary columns. Okay, it will create multiple binary columns such that all the categories will have a unique value once we combine all the binary columns. All right. So in this case, it was 3. So in order to accommodate those 3 classes, we needed to create 3 binary columns. Okay. So by this, each category or each class, so France will have a unique representation in its binary form. All right. Understood? Hello. Okay. Let's move forward. Okay. So now what we have done is we have pre-processed the data. We have cleaned the data. Okay. We have done the required changes. We have done the category transformation for the male, female, and also the countries. And I've teach you how to convert. If there are just 2 classes, you will use label encoders. If there are more than 2 classes, then you will use one hot encoders. All right. Then the next part is about the 2 types of data. Like once we give it a data set, we need to divide the data, all right, into the training set and the test set. Now the training set is the data that a model uses in order to train itself. Say suppose I give you a book, okay, or in general, you read any book, say your textbooks. So you are learning from the textbook, right? Now, what comes into your during your exam is the test, like is the test data set. It is the data upon which you are being evaluated on. Your book is the data that you are being trained on. Understood? So similarly, for models, we have two. We basically split the input data, like the data that we give it, into two data sets. One is the training data set, and one is the test data set. Now, usually the split is like 80% of the entire data is given as the test data, while as you keep 0.2, like 20% of that as your, sorry, you give 80% as the training data and 20% as your test data. All right. Now, how do you do this? So for that, we use train test split, which again scikit-learn. Okay, this is a very important library. So from this, you go into model selection module, and then there is a method called train test split. So what happens here is, so in this there are four parameters. Okay. So first is your input data, that is the input that you will give the model. Then is your output data. Okay, that is like what output, the kind of output you're expecting from the model. All right. After that is the test size. Okay, the split. What this means is 0.2%, 0.2, that is 20%, will be the size of the test data set. So from the entire data, say suppose there are data with 100 rows. Okay, that means 20 rows will be assigned to the test set, whereas 80 rows will be assigned to the training set. Now the model will learn over this 80 rows, and it will evaluate itself over the 20 rows. Understood? Then the fourth parameter is random states. Now what is random statement? Random statements is when it is splitting this data, is it randomly splitting this data or is it splitting this data in order? Now, a random state of zero means there is no randomness. Now, what does no randomness mean? No randomness means it will take the 80% from the start till like wherever the 80% mark is reached. So it will take 80% in order, and the remaining 20% it will give to the test set. Whereas if I had a value for random, that means it will take, maybe it will take this much, then it will go and it will take this much. Okay, till like it is 80% of the data set, and it will assign those to the training set, and the remainder will be assigned to the test set. So we basically split it. Okay, so if we have 100 rows, we split it, uh, like 80% is given to the training set and 20% is given to the test set. This is the usual split. It is not a hard and fast rule, but usually it is more like it's a, you know, kind of a standard way of going through the split. Okay, split of data. Most people use this particular ratio, that is 8 to 2. All right. Then after that, so once we have splitted the data, then we apply again. This is a kind of transformation which is called standard scalar. Now, what we do in this is, see, all these values, right? They are different, right? This is just 0, 1. This is a 4-digit number, 4, 5-digit number. Okay, then again, this is not just 0 and 1, this is 2, 8, 7. Then this is a 2-digit number. Then here it is again 0 and 1. Then here there is a 3-digit binary. Then here again 3-digit. So they do differ from column to column, right? Even though in the row they almost consist, sorry, in the column they are almost consistent, but if we look like this and this, they are totally different, right? This 2-digit, this one is like 5 to 6, yeah, it's 6-digit. So what we do is we try to, convert all these to like a smaller value or a value that revolves around zero, maybe in a range of 0 and 1. Okay, so this will convert it like maybe in a range of 0 and 1. This is already 0 and 1, so we don't need to do anything. This is also almost decent, but we can still convert it into a range of 0 and 1. Again 0 and 1, 0 and 1. Like, so for all of this, you will apply a standard transformation. Okay, or you call it a scalar. So what we do is we scale it to like a particular range. Usually it's a range or like around the median. Okay, or the different terms in statistics. You can go through statistics. Statistics is quite useful in machine learning. Okay, compared to calculus. Calculus is actually important, but yeah, statistics is equally important. So what we do is we scale all this data, in a particular range. Now, how do we do this? Again, scikit-learn, pre-processing, standard scaler. So pre-processing, by now you all must have observed that it's mostly used for basically pre-processing the data. So go and read through the different methods of preprocessing. So standard scaler is another class. So you create an instance of that class, and for X train, see we okay. Now in this train test split, this function returns four outputs. Okay. So first is the X train, that is the input for the training. Then the S test, that is the X test, that is the input for the testing data set. Then we have Y train, that is the output for training, and the Y test, that is for evaluation. Okay, so what we do is we apply the standard scalar transformations on X train and X test, basically on the input data, because output is already 0 and 1, so we don't need to worry about that. And also we expect an output of like probabilities. So we'll be applying the transformation on this input data. Now what we do is we give it the, okay, so SC class. So you created an instance of standard scalar, then you applied fit transform. So by now you all have also seen that fit transform is a widely used method for transforming your data. So what this will do is it will basically calculate the median. Okay. So for this it will calculate the median, and then it will basically normalize. Now, okay, there are two methods of basically converting the data or scaling the data. One is normalization and one is standardization. Normalization means basically fitting the data into a range. Say this entire data, like this is a 5 digit, 6 digit, 7 digit, right? So we can fit it into a range of 0 to 1. So maybe this goes like 0.3 or 0.8. Okay. So in that way, it is in a range of 0 to 1. Now standardization is standardizing it around a particular value. Maybe find the average of this. Okay. We find the average of this, and then other all values are right like around that particular value, or not the average, consider the median. Okay. And then maybe, or even the standard deviation. So the other values will be revolving around this particular value. Okay. So these are the two methods. So here what we do is you don't need to worry about what kind we are doing. Mostly it's standardization when we use standard scalar. All right. So that is taken care of. So what we do is we use fit transform. Fit basically calculates these values, say suppose the median or the mean, and transform is it applies that particular value on this entire data set and converts it into a more understandable data for the machine. So the input we give is X train. So we give this thing itself as the input, and we basically update the X train to the new transformed data. Okay. So if I want, I'll run this and then I'll print it also. So I'll just print X train. X test will just be those same thing with different values. So if you see here, all these values got like they are centered around a particular value. So for these, it's either maybe from -2 to 2. Okay. Then for this one, it may be from 0 to 1. I guess it's this one, right? Yeah. So this is the last column. So this is second last. So this got transformed from 0 to 1. I don't think it is. Maybe. -1. Okay. Yeah. So the thing is, it basically got transformed around the. This one was, I think, around the mean. Okay. This one was standardized. Okay, around 0 to 1. So that was okay. So once all this is done, right? See, we got the initial data. We took care of the missing values, or maybe the categorical data. Okay. So we replaced that with zeros and ones, or maybe the binary column format. After that, what we did is we applied transformation on the entire. Okay. After that, we splitted the data into the training set and the test set. Okay. After that, we applied basic standardization. We standardized the entire data set into a more understandable data for the machine. So once we do this, we have our data set ready. Okay. Then what we can do is run. Okay. Now this part is what we have done yesterday, basically the model architecture. So sequential class, inside a class, we add the first hidden layer, the second hidden layer, the third output layer. Okay. Then we compile it. Let's compile. We compile it. Now we fit this data. So if you see, the first is the input. Okay, the input data for the model. So the input that we will give, the output that it can learn from. Okay, this is already the data that it has been observed. So it will look at this and it will learn. Okay, so for this input, I got this output. Then after that, we have batch. So this entire data will be divided into 32. Like this to this is one batch. Okay, this entire is one batch. Then the next batch will be from that to 32. Like each batch will be having 32 rows. And after that, epoch. Epoch is the run through the entire data. So through the entire, see, one epoch is once you've covered all the rows of this data set. Okay, the second epoch will be again starting from here and going through all the rows. So we will have 100. So let's run this cell. It will take some time. So by the time it gets completed, if you all have any questions, you all can ask, or we can just discuss some other topic related to it. Yeah. Did I lose? Actually, should have completed at least 25. Okay, do you all have anything to ask? By the time it gets completed, it's gonna take some time.
Two doubts. Back to importing the data set.
Yeah,
Uh, like one thing was about the topmost row where like the stuff is written right, row number,
yeah, yeah,
customer, surname.
yeah,
I mean, since we are importing the data set from like no limit to no limit, basically for the whole thing,
yeah.
I think that's what it is, not like nothing, then the colon and nothing. That means that, right? So, like, okay, like the rest of it is all data. So just that's just one line with the labels.
Yeah,
I think
so
that'll
the
not
thing
inter.
is, sequential class does take care of. Okay, so even though we imported the entire data, it will ignore the first row. It will identify it as the naming of the columns.
Acha, okay, okay. And
Right?
next, like about the columns that we are selecting for uh, processing or whatever.
Yeah,
So again, that was like what we did was like left to right or whatever, like some index we put for the column,
yeah,
continuous this thing. But like suppose even though like one part is like organizing data, right? Like suppose like
mm.
irrelevant stuff like row number, customer, surname on the left side and stuff like that. But suppose it's like there's a column in the middle which is irrelevant. So then you'll have to like select maybe
So
more
what you can do in that case,
ranges or something like that. Oh, that's like also not
you
that
can
big a issue.
basically split the data and then combine it. All right. So
Huh.
say
Oh,
suppose we had 3 to 12, right, in this case. So what we'll do is 3 to say suppose the seventh one is the unwanted one. So what we'll do is first take the column 3 to 7. So basically it will avoid 7 and it will take till 6, and then from 8 to 13. So it will avoid 13 and take till 12, and then you combine it. So by that way, or maybe there is a way where you can uh, just ignore one of the mid columns.
acha. And that is like a little bit like all the I don't know array or something that kind of
Yeah, yeah.
syntax similar to Python in general. Okay.
Sorry, pardon, I didn't get what you said at the end.
Nothing, nothing. Forget that.
Okay, you can ask. It's fine. Did our model complete it? Okay, it's on 29. It's gonna take a long time. Oh, sir. Oh no, it's done. Yes. Okay, so the thing is the training is completed. Okay, so we'll continue. If you look over here at the start, when it started training, it had a loss of 0.59, which was a bigger loss. All right. Okay, one important thing is don't confuse yourself with loss and accuracy being the same thing. Okay, Loss is like how close this value is to the actual value. Whereas accuracy is how right that particular value is. I'll explain it further. Okay, I'll give you an example. Then you will understand. So if you see here, we had a loss of 0.59. As we went down, the loss decreased. Visible, right? Cause it's. Am I still there, or did I lose?
Yeah, yeah, yeah.
Okay. So if you see here, the loss keeps decreasing. Okay, and then at a certain point, yeah. So you'll get the minimum loss. That is, you won't get the minimum loss. You might see, okay, here itself the loss is 0.331. Here it is a higher loss, that is 0.33. Okay, so this is how you optimize, like how you'll optimize this is next time. Either you will decrease the number of epochs. Maybe next time I keep it to 99, and maybe I get a lower loss. Okay, but it won't be the same every time you run the program. Okay, in certain cases, maybe this last step, the 100th epoch, may end up being the most effective, the most means it may end up having the lowest loss, while at in certain cases you may have like the 86th epoch being the one with the lowest loss. Okay, but it's always that once you go towards the end, you will have a better basically a more better accuracy and a lower loss. All right, so that was for the training part and the way the model learns. So if you see the cost function is being applied, so this you get from the cost function, and then you use the optimizer that basically goes back and adjusts the weight accordingly, by calculating the gradient descent and all that. Then after that, we perform evaluation. Now, if you see what we have used here, okay, is just the training set. See, both X train and Y train. We have just used the training set, whereas the X test and Y test haven't been used yet. So in this X test and Y test are basically used for evaluation. Now evaluation is basically evaluating how good the model has been trained. So if we run this, okay, if you see here, okay, here you all will understand why I was telling to understand the difference between accuracy and loss. If you see here, the loss is very minimal. It is 0.32, but the accuracy as well is 0.33. All right. So what has happened here is, let's open Paint. So what the loss cost function did is it. So we, if you remember, for the cost function, we used binary cross entropy that basically calculates the closeness between the actual value and the predicted value. All right. So now let's understand with an example the difference between accuracy and loss. Okay. Say suppose the output of our model was 0.55. Okay. And our actual value was 1. Okay. Say this is the predicted value. Okay. Say I cap. And y is our actual value, what value it should have given. Okay, this is the right output. Now if we calculate the difference between this, okay, so if we apply the cost function, okay, so 1 minus 0.55, okay, just imagine there's 0.55 over here, and then we square it, so we should get something upon like 0.45, right? Okay, that is 1 2 16 okay, around this value divided by 2. So around eight something is the is the this, what do you say, cost. Now if we go, okay, sorry, it is 0.8. Okay, the point comes over here, so it is 0.08. Now if you see here, there is a cost of 0.08. Okay, it has a difference of 0.46, sorry, 0.45, the difference between these two. Okay, now whether it is correct or not, so how do we do this? We take the output and we say if it is greater than 0.1, it is 1. So in this case 0.50 is greater than 0.5, that means the output will be 1, which is correct. Okay, even though it is far away from 1, there is a gap of 0.45, but still the output is correct since we put this condition. Okay, now what we do is we go and we run another input. For that we get an output of 0.45 for the same for the same actual value. Okay, this time we get 0.45. Now if you see here, the gap is 0.55. Okay, the gap between these two from this to 1 is 0.55, which is approximately the same, like 0.45 and 0.55, the difference of 0.1. There's a small difference, okay, between these two. But according to this condition, we return 1 only if it is greater than 0.5. In this case, it is less than 0.5. So what we do is, means what output we get is 0. That means our answer is wrong. Now this entire thing, the output, this is means basically this decides the accuracy, while this value decides the cost. Okay, the average cost or the average loss. So if you see here, we'll get around the same average. But if you see this, the outputs are totally different. In one case, it is getting 100% accuracy. In another case, it is getting 0% accuracy. So that is the difference between accuracy and loss. Now, if we go back to our code, the same thing happened here. The loss is minimum. Okay, that means the values are around a particular point, but the accuracy is very bad. Okay, so in this model, we are having a very bad accuracy. So now what I want you all to do is, I'll be ending the meet now, or if you all have some question, you can stay. But what you'll have to do is go back. Okay, if you see the structure, see this part of using sigmoid function is going to be the going to remain the same because you want probability. Rectified linear unit is going to be it's going to remain the same because we want to avoid leniency. Okay, formation of any leniency into the model. Now Adam optimizer, again, it's efficient because it like combines not root mean square propagation and what is that? Stochastic gradient descent. It combines this both. Okay, so it's again efficient. So this is going to be remaining the same. But what I want you to experiment is you'll try adding more layers or you'll try deleting layers. Maybe you'll try only with one hidden input layer. Okay, or maybe you'll add a third hidden input layer. Maybe you'll change the number of this neurons. Maybe you'll make it even you can try with 50. There is no any limit. Okay, maybe I'll change it to 7. Just experiment with it. Okay, then apart from that, you all can change the batch size. Maybe you all make this 42, 106, whatever you all want. Okay, maybe change the epoch. Try putting different values for the epoch. Try running through the dataset for different number of times. Okay, so make changes over here, and tomorrow I will basically be checking for the highest accuracy. So for the ones like if you all are able to get a high accuracy, see once you all run this particular line of code, right? Where is it? Here. If you all are able to get 885, okay, around 85 over here, it's excellent. Okay, that means you all have understood each and everything that has been going on here. All right. So try basically, playing with those values over there, whatever I told. So see, number of neurons, okay, number of layers, you'll delete, you'll add, whatever you want, the number of epochs, the batch size. If you all want, right, change even the activation function. Okay, as long as you all are getting the accuracy right. Because see, once you all are getting the accuracy around 85%, that means your test set and basically your model has performed really well over the test set. Okay, so 85 is a really good number, and usually it's 85. We don't go towards 90, 99 and all because that will make it more linear and we don't want that, or it will fit it exactly to the data set. Okay, so tomorrow some major like some noise has been introduced into the input values, so it won't be able to predict like perform that well. So we need to keep some amount of noise as well, some amount of randomness into the model. Okay, so for that 85% is usually taken. Then after that, do run this one and tell me what your answer is. Okay, do run this particular code. So this I'll be checking tomorrow. Now, apart from that, how do you save a model? Okay, so last part for this particular section of ANN. How do you save a model? So it's basically ANN.save. Simple. So you have created the instance. So this is an instance of the sequential class. So you'll basically apply the save method and save it with the extension of .h5. Okay. So this model gets saved. Next time, when you want to use this model, basically import this model. Now, how to import? From Keras TensorFlow models, use the method load model. Okay. So the load model will basically, it will load your entire model with the weights to the variable, basically to the variable that you are named. So suppose I name this pp, it works. Okay. So it will load it to this particular variable, and then you all can predict. How you will predict? Use the method predict. Okay. So once you have created this, ann underscore loaded dot predict. Okay. And then basically give it the input. Now you all in basically for tensor. Okay. You all give it into a form of a 2D array. So you all will have two basically square brackets, and inside that you all will give the input values. Okay. And just don't paste these values, okay, into the predict. You need to transform, because here previously in the step, while training, before training the model, we did transform, right? Where is that? Here, selection. Yeah. So here we transformed the entire data around their values, right? Either by calculating the means, all that. So similarly, now when we give it the input, we need to transform those inputs as well. So if you see here I have not done fit. Okay, I've just done transform. Here you're not calculating anything, you're just transforming it. The values, see, once you load the model, those values are already present there. So using those values, you need to transform this. You don't need to create any or calculate any new values. Alright. So once we transform this, basically run this, and then you can print the prediction. Alright. So all this we will do tomorrow again, once you all basically come with your model. So try to get around 0.85, 0.86, 0.83 works. Okay. So yeah, that's all for today. So tomorrow, do you all want an offline kind of a session tomorrow? Should we keep it offline or online itself? Because offline you all need to be free. Okay. Maybe after 2. Hello, are you there? Online. Okay. Okay, we'll have it online. So what I want you all to do is go through this code. Okay, create a copy, because do you all have access towards editing this code? I don't think. Do you all have access towards editing the code directly? Anyone could check and tell. Oh yeah, slicing. Is it uh, open to you all to edit the code directly? Because if it's, I need to change. Can you all hear me? No? Ved, you're saying something? Okay. I can't type it. Type it.
We can hear you. I'm just trying to check if we can edit it or not.
Oh, okay. Yes. Also, I may upload this video on YouTube, so if you all want to go back, you all can refer to it. Go back through any of the sections. You all can refer. Or those who have missed the lecture, you all can edit. Okay, okay. Don't edit it for now. What you will do is create a copy. Okay, so if you all go over here, you all can see. Where is that? Okay, it won't come from. So if when you'll go, you can basically create, save a copy in Drive. Okay, so save a copy in Drive and then you'll edit it. Don't edit it here. Here, like let's keep it uh, common so that everyone can refer to it. Okay, so create a copy and then you all can basically edit it. Right. So yeah, do you all want any other thing to know, like what other changes you all can make, or do you all have any question? Because see, if we complete tomorrow this, then after that, basically, I'll do a quick session on using pre-trained model, and after that, CNN. Because by this week, I wanted to finish CNN, but I'm not sure. Tomorrow is Friday. Hmm. Tomorrow is Friday. Friday, Saturday, Sunday. Because if we don't finish CNN by this week, we might have to cut on the other topics. Because RNN will take some time. It is a little bit complex compared to both of these methods. Also, do you all want me to take a session on the mathematics behind these models, behind these methods, like the linear
Yeah.
one? I'll see if it's possible because the time is
Yes.
very limited. Because see, you all won't be using the mathematics much, okay? You all will be directly using the class and all. And I need to make you all ready for that hackathon. So for that, it's mostly like it's important that I teach you all about all the classes. Okay, the methods or the way the function basically change the values or the layers how they interact with each other. So in general, I need to tell you how things work. The mathematics is interesting, but again, it's not important towards applying it. See, it's important, like if you want to understand, you all want to go forward and create your own layer. Say tomorrow you went and you made a new layer that interacts differently, all right? Or you made a new activation function. In that case, it's important. But if you're just going to build models, if you're going to, focus towards the application of these models, then you'll need to know the classes. See, for hackathons and all, तुम वहाँ बैठ के maths थोड़ी ना करोगे. You'll be building the models and applying those models. And for 12 hours hackathon, 24 hours hackathon, it's not possible to build a model over there. Because if you see, training a model takes a lot of time. Because even if you have the proper architecture, the proper data, the model in one shot is not going to give you the highest of the highest accuracy. Okay, it is going to take time. See, it's like a child. You give a book to a child. Okay, maybe that, say there are 10 children. Okay, you give books to them, different, like each of them will learn differently. Someone may be doing extremely well, someone will not understand anything. Okay, someone will be doing average. So it's like that. Models are like human brains itself. Okay, it's like our brain. It learns from the data. Sometimes maybe it doesn't learn properly, maybe a particular feature got missed, or maybe it overlearned a feature. All right, so yeah, so it takes a number of tries. Okay, you need to tweak the parameters. So what I basically told you all to do is tweak the parameters. Now by doing this, you all are also basically learning to fine tune models. All right, even though it's a completely different, it's somewhat different method compared to what I have given you all as the homework, but still. So yeah, was there anything left to tell? If you all have any questions, you all can ask. For even for the third years, right, for your internships, you all will be mostly dealing with pre-trained models. So if you all are handling the ML domain, okay, so you all will be tweaking the parameters. Maybe you all will fine tune, and now even fine tuning is mostly done by companies, right? So say suppose you all are working in those companies, your main the time where you'll be spending the most is fine tuning the models, or maybe introducing or another extension to an existing model. Basically, you need to like play around with models to understand, what can be done to improve a model or to suit a model for a particular case. So yeah, there's a lot that we can talk about, in terms of training the model. But then it's about the time also. First, you'll get time, right, to do your other work apart from college ka kaam. You'll get time for extra skill development. Am I audible?
Yeah, yeah. Mm, yeah, there is time, I guess.
Oh, great, great. Utilize it properly. What about third years? I guess you'll have time with third year people. Jeet Asare, yes. Jeet and yes. Right. Yes, Jeet left, right? Yes. Y'all can leave, okay? We are done. Just make sure tomorrow's model. Oh, okay. Tomorrow's model. Y'all basically find adjust the parameters and then we'll see. I'll also try if I get time. Is it? Because by now you'll have the basic structure of ANN and yeah, you all have the data. The data has been processed, so you all have all the things. Okay, one more thing. While you all are running this code, right? Once you open this, go here and then basically upload the file from here. Okay. So from the this right drive, just download it because otherwise you will need to change the code for importing the file. Okay. I forgot about this thing. So what you do is basically upload the file from here, download it first, and then upload it. Okay, and then you can use it. Then it will work fine. Otherwise, you will get an error because if this is an audio, you'll get an error. So just do that. Even though the thing is the file, the folder of the data set is the file of the data set is still there in the drive. Still, you all need to download and upload it because the code is in that format. All right.
The Excel one, along with what
Yes,
we
yes.
modified, we upload that together.
What? I didn't get it.
Basically, like once we downloaded the copy of the
Yeah. Yeah.
collab
Just
thing,
upload it.
upload it along with the data set again.
Yeah, that's the data set, right? The CSV is the data set.
Mm-hmm.
Yeah,
Yeah,
that's good.
cool.
Yeah.
Chalo, bye.
Yeah, chalo. Bye. If you all don't have questions, you all can. Good night. Bye.